from traditional to sustainable construction through 3D printing. What is the 3D printing? A new automated technology that works by modeling the structure using CAD software and is then printed by 3D printers. Why 3D printing? 3D printing is an eco-friendly alternative as it generates less waste. It eliminates the need of casting concrete in molds or formwork and hence ensures less usage of raw material. It is a fast construction technique that accelerates project delivery and saves time. Less labor is required through the automated construction process. It allows greater design flexibility and customization. 3D printing cuts off cost by utilizing almost exact quantities of material and reduces noise pollution caused by traditional construction techniques.
Despite all the advantages 3D printing possesses, it still utilizes conventional raw materials like cement and fine aggregates, whose manufacturing and extraction have negative environmental impacts. Conventional raw material replacement. Construction is one of the most demanded industrial activities worldwide, where more than 10 billion tons of concrete are currently produced to satisfy this demand. More than 4.1 billion metric tons of cement are produced annually, which are causing the exploitation of natural resources and increased levels of pollution, where CO2 emissions exceed 2.46 billion tons. Some industries produce high amounts of byproducts that have shown a great potential to partially or fully replace ordinary Portland cement. Out of these materials, silica fume, a byproduct of silicon metal production, ground blast furnace slag, a byproduct of iron production, metakaloin, a calcinated form of the mineral clay at very high temperature. Based on experimental work, replacing cement by up to 15% silica fume, 20% slag, and 15% metakaloin can give optimal results and reduce the environmental impact of cement by 50%.
Another construction problem the world is suffering from is the large amounts of construction and demolition waste that originate from demolition and repair works of structures and pavements. Natural disasters, war, where about 145 million tons of C&D waste are annually produced in the US. The fact that urges us to find a solution to reintegrate these wastes into the construction cycle. Around 40 to 50 billion tons of natural non-renewable sand are extracted annually for construction purposes, and finding a replacement has become necessary. Here comes the role of recycled sand, a result of crushed construction and demolition waste that has shown a promising potential to fully replace natural sand in the 3D printing mix. 50% cement replacement and 100% natural sand replacement will ensure a more eco-friendly mix and elevate the advantages of 3D printing, making it a highly promising alternative to conventional 3D printing mortar mix.
But despite the solutions 3D printing possesses on the construction industry, its applications are still limited due to the missing structural aspect. Integrating structural steel into 3D printing. Many reinforcing methodologies were tested throughout the years, and the results altered between efficient and non-efficient. Our adopted technique includes casting 3D printed modules with holes at each corner containing transverse manually placed stirrups. These modules are then bonded together through epoxy resins, and longitudinal bars are inserted through the 4 holes. Finally, grout is injected inside these holes in the direction of bending for better bonding and retarding crack formation. How can we make our structure more eco-friendly? The traditional grout mix can be replaced by a geopolymer, which is an alkaline activated binder mix of solid aluminosilicate precursors that are byproducts of industries with an alkaline solution. Geopolymers are environmentally friendly and show a great potential to replace cement-based mixtures. Filling the holes of the 3D printed cement with a geopolymer grout of 40% metakaloin and 60% sand enhances the properties of the grout.
Our proposed solution is a structural 3D printing with recycled materials and byproducts for the mortar mix grouted with a geopolymer-based grout material to bond inserted steel bars to the printed layers and reduce crack formation and propagation. This methodology minimizes the massive environmental impacts caused by traditional construction and is our ticket towards sustainable construction.